Good morning, class. Today, we are going to look at the moving parts of an internal combustion engine. Again, we deliberately chose this just to motivate the drawing, features, and sketching, and so many other things we will learn. We just use this. It's always good to have something you are aiming at. So we are aiming at making the internal combustion, the internal parts of the moving parts of an internal combustion engine. It may be of interest to you to read more about it, especially if you can read about firing sequence. That will be useful for the next class. If not, you just cram whatever I tell you. But if you read about it, you will actually be able to make an engine on your own, whether it is a petrol engine, diesel engine, or even an electric vehicle. I'm thinking that some of you may take projects such as making a lawnmower, the pepper grinder, and some small equipment or large equipment or a big 20-cylinder generator or some other equipment that you can do all the design on your own from this course. Those are the kinds of things that are possible, and those will encourage you to take it seriously. Um, so uh, previously, we used 7 align centers and created a connecting rod. We did this by extruding simple 2D sketches to the third dimension. In today's class, we shall modify that connecting rod to make it more useful for maintenance purposes. The connecting rod we did the other time is good for drawing, but you will see that it is not a very useful equipment, not a very useful component as it is. So we will do things to it to make it more useful. We shall also create a piston and a single crank for a single engine motor that it will attach to. From that single engine motor, we will be able to create a V6 engine, a V8 engine, an inline 6 engine, and we will put all the kinematics and motions, and we can simulate or animate those things. Maybe by after this lecture, we will be looking at that, depending on how you take it. So the purpose of this class is to make more advanced use of two-dimensional sketches. We are going to be creating 3D objects, but we are going to make advanced use of 2D sketches. And to include more 2D sketches, understand the use of existing parts as limiters. Before, when we want to extrude, or we will just say extrude by this amount of millimeters or centimeters. Now, you will see that we can do our extrusion by saying, okay, extrude until you hit a body, or extrude and cut everything on its path. All those kinds of things will be a more advanced use of existing parts. So you do extrusions of the sketch profile plane. So you might start an extrusion, but not exactly on the profile plane, but on an offset plane. You see why that can be very powerful and useful. That will reduce the number of cuttings and clippings that you will do. And we'll look at more parts using revolve. Then we will look at component creation from existing bodies. You'll be seeing that sometimes we have a body, sometimes we have a component. You will see that we can make components from bodies. And after some time, questions will arise in your mind. What is the difference between a component and a body? What we will do in this class is to know how to make both of them. And then by the next class, you will see that there are certain things you can do with components, but you cannot do with bodies, especially when it comes to the assembly of parts to make an engine or to make a more complicated body from simple ones. You will see that the 3D creating tools allow you to create fresh components directly from scratch. So you can create a component from an existing body, or you can create a component from scratch. And what allows you to do, the 3D creating tools allow you to do either. So you might decide that out of a number of bodies you've already created, you can join them together, combine them, and make the combination a component. Or you can just create a component straight from your two-dimensional 3D modeling feature properties. So we shall see the use of this method subsequently. Piston and the connecting rod. And this, what we have here is a reasonably practical piston and the connecting rod. You will see that when you get to the bottom of the connecting rod, it is sort of cut here. It's not like the connecting rod you made the other time. So this picture shows a working piston and a connecting rod in an internal combustion engine. The connecting rod looks like the one we did 2 weeks ago. One of our goals here is to modify what we already have so to look like the one we have here. What do we do to that one so that it will look like this? And why? Why should it look like this? We will look at those two questions. We also make a piston like the one here in 2 steps. First of all, we make a simple piston and then we modify it with the required internal parts so to look like this one so that it will have a place where we can attach the connecting rods to. The original piston will not have that, but by the time we edit that piston and do some more things on that original drawing, you will see that we'll be able to do more with it. First of all, let us demonstrate why the piston we created last time is not good enough. This is the piston we created last lecture. We just used 1, 2, 3, 4, 5, 6, 7 circles, and we just joined the circles with some flexible lines, splines. So we just joined them with the splines, made sure the splines are tangential to some of those circles we did before, and we got this. Now, this is the shape of a typical crankshaft. Now, you will see that if you have this as a physical object and this as a physical object, it is not possible to put this inside this place. You want to put this inside this place and it is not possible. It's either that you break the crank or you break the connecting rod, neither of which you may want to do. So we're going to instead modify this connecting rod so that we will be able to fix it into this. This in a typical 6-cylinder engine, you're going to put 6 connecting rods onto this. And so you cannot break the crankshaft 6 times. So there must be some better way to do it. So into this kind of crankshaft, you may have to insert, you are not seeing the whole crankshaft, it's much longer than this. But if you want to insert this, that will be a problem. In this, by the next lecture, you'll be able to make a crankshaft like this. But right now, let us just assume that we will have a crankshaft and we want to insert this into the crankshaft without breaking anything. How do we do that? Now, this is an example of a crankshaft. As before, I'm going to make sure that my volume is very low. And when you are using the videos you have, you'll be able to listen to the voice I had in recording this. But in class, you will not be able to do that. So let me just go back to my slideshow from the current. Okay. So in this particular case, let me just play this to just show you how the crankshaft looks like. So the crankshaft, this is a 6-cylinder engine crankshaft. So this is what it looks like. It is a very funny shaped object, but you will be able to see why it looks like this and what we are trying to achieve, what is being achieved by making it look like this. You will see that in due course. But what it tells you immediately is that if you want to put a connecting rod inside this, there is something you must do to the connecting rod. For instance, we said modify connecting rod. There are 3 stages. You begin with the connecting rod we did last week. That's the one created with the 7 circles. You use the split tool on the offset. You use a split tool on offset planes. Yeah, you do a half sketch shown in the slide below to create the bolt feature, what we hold deep, and then you use 2 mirrors to get the full features on both sides. And make components out of bodies And you do this by using the XY plane as cutting tools. And you will get everything in two components color. So from here, you move to here, then you move to here, go anti-clockwise here, and the final thing will be like this. It is a little bit clearer in this picture. This is what we did last week. The first one on the left is what we did last week. The first stage is to clip the two sides. We clip the two sides. We show you how to do that. And after clipping the two sides, you are going to put the holding feature on both sides. After you have put the holding feature, you are going to do another split. And then you make two components. You make a component on the top part and make a component on the bottom part. The bottom part we are going to call the connecting rod head. And then the rest of it, we are going to call it the connecting rod body. So those are the things that those are the steps we're going to take. These steps are given to you fully, in a full video clip. Before I show you this slide 9, I think it's better let us see how we do the clipping. This is how you start. You start with the object that we had last time, and I'm sure you'll be able to make this object yourself by using a number of circles. So the first thing you then do is turn on the origin, and you go to pick a construction plane. And pick a construction plane, you are going to pick an offset plane. The offset plane is an offset of the ZX plane. So if you take an offset of the ZX plane and you do it at a distance of 30 units, you do it as just 30 units on the y-axis, and then that is one plane. Then you do another offset plane. You take another offset plane, you take it backwards to minus 30 on the y-axis, and then so just say minus 30 there. So you have two offset planes. You are going to use those as splitting tools. So you are now going to bring from modify. You are going to bring down the body split, split body or in the drop down, and the body you want to split is the body of the connecting rod, and it is asking you to what body to split and then what tools you want to use. The tools you want to use are the two offset planes you created. That is one, and then this is the second offset plane. So you take those two offset planes and you say okay. When you say okay, the thing has been split, and you can notice that in the body count. You see that there is body 1, which is the small thing. You have then body 2, and then body 3 is the main body. So if you switch off body 1 and body 2, you get what you are looking for. Okay, so you can see what you have now is like the second picture, which is a split of the body into 3. You have cut out some flat part from that body. So when that is done, you have succeeded in the first step. So with what we have done now, we have moved from this situation to this situation. The next thing we need to do is to come to this level. To come to this level, we are going to go to the XY plane, and we are going to create this profile. We are going to create a profile to make this body. So that will be the next thing to do. And this is the profile we have chosen to use. And this is the profile here that, because once we have this profile, this is actually half profile. That what it means is that from a distance of 36.5, from a distance of 36.5, you are coming here to draw a circle of a diameter 15 and make tangent to it here, and then you cut off the materials that you don't need. I think there's a full video demonstration of this one too. The full video demonstration of this, let us go and take a look at it. So the first thing you do is that you make, okay, am I getting the correct video? No, this is not the correct video. Let me just stop this one and move up. Well, I don't think I have that video here. So here you use this profile to make, just by extruding on a profile like this. This profile is easy to make. So the profile here, you start with a 15 diameter circle at point 36.5 here. And then once you make once you make this tangent to it, and you take off bodies that you don't need, and you do another circle of radius 8 here, by extruding and doing mirroring, you'll be able to get what we have next. So let us move to the next. Let's move to the next object here. Let us see what this is. If this is not what we want, then we'll just move on. Okay, so this is what we did before. That is the splitting tool to cut. So that we've done that. Having created the holding feature on the connecting rod, the next step is to make two components out of the connecting rod. And to make the two components, we're going to call one of it the connecting rod body and the other one the connecting rod head. So let us, we achieve this by creating another split tool. In this case, this useful split tool is simply the XY construction plane that we were given. There's no need to create a new plane. So this is how, after we have made this tool here, by extruding and mirroring twice, we should be able to get this. We will do one mirror to complete it, another mirror to put it on this other side. So when we want to do the next thing, what we do now is what we want to do here is to use the XY construction plane as a split tool. So we will use it to split this. There are three bodies here already. The body one is the main body. Body two is this holding thing here. Body three is this holding one here. If you look at the, it will be body three, body four, and body three, body four, and body six here. So when we cut it into two, before we cut it into two, we are going to make everything into a component. Let's see how we do that. To make it a component, you right click on one of the bodies like this one, and that will give you a menu that is create components from bodies. So once you click that, it will turn that one into a component. So once it has turned that into a component, then the next thing is to take the remaining two bodies. Here now it will be bodies 4 and body 6. So you are going to click on those two and join them to the component. So the first thing is you rename the component connecting rod body. Okay, so connecting rod body. And then once you finish that, you are going to take the remaining two bodies and drag them inside it. That's the first one. That's the second one. You are going to drag both of them inside so that you now have three bodies inside that component. And if you look at the body count, it's now reading body 1, body 2, and body 3 inside the component. So after that, you are going to do a body split. So for modify, you bring down the menu and choose split body, and it's asking you what body to split. So you are going to select the three bodies. Those are the bodies to split. And then the next thing is splitting tool. The splitting tool, instead of creating anything new, you are going to choose the XY plane as the clipping tool, the splitting tool. So that is it. That's split tool. It didn't choose it, so you have to do it again. Select the bodies again, modify, split body, and then choose the bodies, and then choose the splitting tool, which is the XY plane. Yes, okay, so that is the splitting tool. It's going to use that to split the body. And once you click OK, you can now see the body count has moved from 3 to 6. So you are going to select the bodies that are up as one set of bodies, the ones that are down as another set of bodies. So you again click create component from bodies. So that is right click, create component from bodies. Okay, so the remaining bodies that are associated with that, those are the remaining two. You make that body instead of putting it under the old component, you put it as a new component on its own. Okay, so these three bodies are now to be renamed the connecting rod head. Okay, connecting rod head, con rod head. Okay, so once you have done that, you will see that so you have the con rod and the con rod head, and because there are two different components, they are colored differently. So you can see now that there are two components, and their connecting rod is no longer looking too much like what we did before, but like a new connecting rod. So if we really look at it very closely, we can move that and rotate it a little bit away, so you can see how you can see the meshing surfaces of the two connecting rod bodies and components. So that is it. There is the one that is the connecting rod head and the one that is the connecting rod body. That is the surface on which they are meshing, and it was caused by the splitting body, and the tool that was used before we now turn this one into a different component. As the picture here shows, the connecting rod is now made up of two components, the con rod body and the con rod head. The two can be bolted together, as we can see, and thereby installed into the crankshaft easily. So with this kind of arrangement, there's no problem again to insert this into the crankshaft. You can put one on top and bolt the other one below to it, and that's it. It doesn't matter how many. So this is how we make a practically useful component out of the theoretical component we made earlier. So we can, finishing the component, we can now add bolts required to complete this part. There are two ways we can approach it. We can create bolts object very easily by extrusion, and this is not a difficult thing to do, and you may want to go ahead and create your own bolts to put in those holes. We can also buy a bolt from the market. There are within the Fusion 360 environment, you can go to a real market where you can pay money and buy bolts and get the drawings of those bolts to put in your design, and actually receive them physically to use. So that's something we will explore sometimes later. We'll use this method later. So that is it for connecting rod. Let us now look at the piston. Here is an example of a simple sketch to create a basic piston, including grooves for the piston rings. The grooves for the piston rings are at this one, and this one, depending on how many grooves you want your piston rings to have. So we can have those grooves. In this sketch, the exterior profile of the piston is created by revolving this simple sketch. A revolution of this simple sketch along the z-axis will give us a very simple piston. And once this is done, we will then need to add additional sketch to create the internal parts for attaching the connecting rod to the piston. This will include extensions, bolt holes, and a clearance for the expected motions of the connecting rod and the piston as the piston moves in a reciprocating motion. So when they are moving in reciprocating motion, there will be need to give some sufficient clearance for the connecting rod inside the piston so that it will not hit a part of, once it hits a part of the body, then that's that your design is wrong. So these are the kinds of things you'll be able to do. And then I have a video clip of this, of what we're talking about here. In the video clip, I will create the sketch, and then maybe in this one or the next, we'll do a revolve. So let's see how we do that. So we start with create sketch, And then we are creating this sketch on the YZ plane. And then we use the pan handle to move it down. And then once we are happy with that, what next do we do? We can from there go take the line drawing tool. In the line drawing tool, we start somewhere up there. We draw a line up, and then that's about 5 millimeters. And then we go to the right. In the video, I said go to the left, but just watch where I actually go. I went to the right. You could have gone either way to work both ways, but here we went to the right for about 50, then come down for about 50 millimeters again. And then we go left now for about 3 millimeters. Go left about 3 millimeters. It should be horizontal, but it doesn't have to be because we can use the constraining tools to do it. And then go up about 20, then a little bit left, and then up again, and then close it. And you'll see that once you close it, it changes color. That bluish color shows you have a close profile. It's only on a close profile that you can do your three-dimensional bodies. If the profile is not closed, it won't work. So you are reminded when you have a closed profile. So let us now use the dimensioning tool and other constraints to put this the way we want. That is 5.5 units there. And then that one will be 45 units. And then the vertical one will be 50 units. We are using our dimension tool, so the 50 units. Down here, there are two things. You first of all want to force that to become horizontal. It is going to be 3 units, but it won't be horizontal. So you need to expand it a little bit. You need to expand it a little bit and use your tool, this horizontal vertical tool. When you click it, you can see that it has been forced to become horizontal there. So that is, and then you need to do a collinearity with the origin. If you take the collinear tool there, collinearity with the origin, those 2 points, collinear with the origin, it forces that to be on the axis, on the x-axis. Okay, so you can still use that, force that to be horizontal, force that to be vertical, then force that also to be vertical. And then the distance from that, or the vertical distance in there, that's an error. We should have picked the dimension tool first. So we have to we go back again, pick the dimension tool. We pick the dimension tool, yes, pick that one, then take that to there. The vertical distance, the horizontal distance there is 7.5. Okay, so we then do the same thing again and get this vertical distance. Vertical distance there is 20. And then the vertical distance between those two is 4. 4. And then, okay, so you now do the same collinearity here. Once you do the collinearity, you are happy with that, okay? Okay, so what is left now is to create the grooves for the connecting rods, for the piston rings. To create the groove for the piston rings, are we doing that here? Yes, we are doing it. So you move about 4 units down, you take your line tool, move about 4 units down and come in, and then do a close rectangle there. Do another one there. Come in, do a close rectangle, second close rectangle, and then third, make another one, and then do a third close rectangle. So we are going to use the constraining and dimensioning tools to force those things to be the way we want. So the first one is 4 units from the top. So you take your dimensioning tool and you take that distance is 4 units from the top. Okay. And then that arm is also 4 units. So you put 4 there. And then the vertical distance is 2.5. So you pick that and you make it 2.5. Okay. And now you are going to use your constraining tools. Those ones will make it horizontal and vertical. And then you are going to take the equality constraint. There is an equality constraint. You take the equality constraint and say, well, I want this line and this line to be equal. So whatever that is 4, so that one will be 4. So you use the equality constraint when you need to, instead of, that is 2.5, so that is 2.5 also. And then what else? The distance from that point to the next point is 2.5. 2.5. Okay. So the horizontal verticals again. Equality constraint for the horizontal. But the vertical here, you want it to be 5. So you are going to take the dimensioning tool. Equality constraint will not be good enough. You're going to take the dimensioning tool and then say that one is 5. Okay, and then the distance of those two arms is 2.5. So the dimensioning tool to the rescue there. So that's 2.5. So with that, we have done the profile of the piston. We've also created the grooves, the profiles for the grooves. So we are ready to go now and make the piston. And once we say finish sketch, we can go to the solid creation tool. And we first of all switch on the origin there. So we now say create revolve. We're going to create revolve. And then we select the profile to be revolved. And then after that, we're going to select the axis. The axis here is the Z axis. So that is it. So the piston has been made, and it's 360 degrees. And if we're happy with that, it's a new body. We click OK. And then we can go back to the home. We can go back home. And then we can now use an orbit. We can use an orbit tool there to look inside to see how it looks like. Okay. So that is how it looks like inside. This is a very simple piston. And with that, we can move on to improving it. We can move on to improve the piston. We're going to need a profile like this. We're going to do, and this profile is very easy to do. You just come from the center there, you move 44.5 up here and draw a line, a horizontal line. Once you draw this horizontal line, and then along here, you also draw another line, a vertical line. In the middle here, you create a circle of radius 20 or diameter 40. That is diameter 40, and you make a tangent to it on this side. Once you make a tangent to it on this side, that means that this distance here is 20. This distance here is 20 with that tangent. And make sure that the center of the circle is located at 16 units from the top. So that is it. So the circle itself has a diameter of 40, but its center is 16 from top here. Then you now move another 5 units down and create another circle of diameter 19.5, nearly 20. So total will be inside here, another one 19. So you have all these circles here. And once you do the trimmings to reduce the unwanted lines. And I think there is a full, let me just see whether this is done. No, let's see whether we did it. Let me see here. Okay. Let's see. Okay, so that drawing, we are assume that we have done that drawing already. So we're going to use it now to make the internal parts of the piston. So to do that, we're going to do an extrusion, and this is the instructive thing. We're going to do an extrusion of this, and to do the extrusion, we are going to start from an offset of 15. So the extrusion is not going to start at the profile plane itself, but it will be starting from an offset of 15, and it will be extruded to the surface here. So we don't need to know the distance to the surface, we just choose the surface. So the extrusion will go to meet that surface. It will start, it is now saying cut, but we don't want a cut, we want a new body. A new body. Okay, so that is it. So you can see, if you look carefully, you see that the extrusion did not start from the profile plane. It started from an offset plane. You can see it there. The extrusion is from an offset plane to the body. It's not a flat area. So that is, so in this extrusion, you are going to do a mirror to get to complete the part. We rotated it so that you can see the plane for the mirror. This is the mirror plane. So you select the body to be mirrored, and then when you finish that, you are going to select the mirror, select the body. Then the next thing is to select the plane for the mirror. So once you select the plane for the mirror, and it's in join now, you want to join the rest of the body to what you just created. And once you finish that, you can see now what it looks like. So you have created a full holder on that side for the pin inside the piston. So with that done, you can now do another mirror. So you are mirroring the new object. You are now mirroring using the profile plane or the that so that it will be mirrored to the other side with the offset, everything with the offset and everything will be mirrored to the other side. So that's it. So So the next thing is that we want to use one of the internal circles to cut a hole through the original profile. So it's another extrusion, but it's an extrusion of cutting this time. It is now to all that can be cut. So everything on its part that can be cut will be cut. And so the distance is to all. So everything that is on its path that can be cut will be cut. So that is how you do this one. So you are not specifying distances here, you are just specifying all. So that is how you have a holder for the connecting rod there, and that's how it will now look. So from the simple connecting rod, we make something like this. The next thing to do is to do a pin. To do a pin, you are going to go back to the original drawing again, and you can turn off the body that is existing so that you can take you did do an offset again to give a tolerance for the pin. An offset is done, and then you can now do your extrusion with that internal smaller circle. So it will be a symmetric offset. And it's a symmetric, it will be no offset here, but it's a symmetric extrusion, and then it can come out on both sides there. And that will be the pin that will hold the connecting rod inside the piston. So that's how that is done. Okay, so we have completed the piston. Now we have completed the piston with the following: a simple piston head, a pin holder feature, a pin to hold the connecting rod inside the assembly. These are shown in the picture here. Notice that we have learned the following. An extrusion can start offset away from the profile plane. We can do multiple mirroring to take advantage of symmetry. Extrusion can create new objects, joining to existing objects, and can be used to cut objects. So you can use extrusion. The extrusion profile can be used as a cutter. So all those things you can do. Okay, so so the next thing is to now make a component. We will want to make a component out of this piston. The component will be in two parts. The pin will be a different component from the rest of the body, the way we will do it. So let us play this. The whole thing is clipped for you. So in your, those of you who have gone through your notes will see that it has been done. So you select bodies and you say create component from bodies. So once you create component from bodies, you are going to put all the bodies needed into that component. So name the component piston. So once you name the component piston, then the other bodies that join it, you click on them, you bring them into it. You click on the other one, you bring it to it. So the only thing left is the pin. And for that pin, which is body 7 right now, you can create a component you can create a component for it too. So right click again, create component from bodies, and then you are going to name that the piston pin. Okay. So once that is done, you can go and turn on the coloring, the inspection you can go to the inspect and look at the drop-down menu so that you can allow it to bring you the colors to show you that there are two different components there. Okay, so you can see now what it looks like. There are two different components there. One is the piston, the other one is the pin. Those are the two components in this. Please go to the chat room and you can place your questions there. When you go on break, I will go through the chat room. I will go through all the questions you have asked me, and I will be able to get your answers to those questions by the time you are coming back from your break. So if there are things to clarify, I would expect to see them in the chat room. Thank you. Welcome back from your break. I think we can move on now. So what we did previously is that we created a modified connecting rod, and we have now finished creation of the piston component. We created a piston as a component. We created a pin as a different component. So we are going to create a relationship between the piston and its pin that we can deal with explicitly. The slide above has a video that created the different components from the bodies of our 3D creation processes. It's easy to see now that we can insert the connecting rod into the piston while allowing the necessary reciprocating motions to be transmitted to the crankshaft for its rotational motion that are transmitted to the wheels of whatever equipment you are creating. We are going to create a single crank. And this single crank eventually is going to become our crankshaft when we finish after several iterations down the road. But initially, it's going to start as a single crank. Again, the profile needed, the necessary profile to do this is simple. Essentially, it is a circle here of radius of diameter 80 units. And then you have tangent lines moving at 20 degrees. And then after that, you make sure that there is a horizontal line that joins them when they are 150 apart. That is only a specific place. And then you can move down a little bit to make it, to have a rectangle below that. That is 25 units. And you can remove the line of this rectangle so that this is a single profile. So you have two profiles, one the circle, the other one the how many sided figure, that one to the 5-sided figure that is there with that ends as tangents to the circle. So we proceed to do the single crank with two sketches on the ZX and ZY planes respectively. The way to do the first sketch is to draw a circle diameter 80 at the origin, a line at 20 degrees to the Z-axis that is constrained to become a tangent. Somebody was asking me to demonstrate constraining. You want this to be a constraint to this, all you do is to pick the tangent constraint and then pick the two things you want. You pick the circle as well as the line. That's all. So if you have been following the class, you'll see that we do constraining all the time. Then we do a mirror along the Z-axis and stop the diverging lines when the distance between them is 150. So these two lines are diverging. You stop when the distance between them is 150. You can make sure this happens by first of all drawing a line and draw a horizontal line and forcing that from the 2 points and then forcing that line to be 150 in length. Then we do a mirror along the Z-axis, then they complete the rectangle 25 units below and delete unnecessary lines. So this is what you will get. The same thing is in this clip. So what I've just described is in the clip here. So to do that, you start by creating sketch, and then you do a circle, as I said. And after that circle, you draw a line inclined. So you are going to draw another line from the center up. So next you do a line from the center and that line goes up. Okay, so you select those two lines, you take your dimension tools. When you select those two lines, it will give you the angle between them. So select the two lines and then using the dimension tool, it's going to give you the angle between them to be right now 16.3, which is not what you want. If you want it to be 20, just enter and type 20 and you get 20. And that will be the angle. And then you can again constrain. To constrain them, you choose a constraining tool and then you select the two of them. It will be constrained to be a tangent. That's the constraining tool. So it's constrained to be a tangent. You can remove the unwanted line there using the trim tool. And then once you've done that, the unwanted line will be gone. Okay. So what next is to do a mirror. You do a mirror of that line to the other side. So take a mirror. So that is on the other side. Then the ends of the line, you force the ends to be 150 by first of all drawing a line and dimensioning that line to be 150, and then that's it. So with that done, what we'll do now is to use the pan handle to move this thing up a little bit. Use the pan handle to move it up a little bit. Okay, and then with the pan handle, then you can now make sure that the dimensions are there. Dimension of the vertical side of that is 25, but you want to make it constrain it to be horizontal and vertical. So the person who is asking me to demonstrate horizontal and vertical, to demonstrate constraint, must have been sleeping in class, because we've been doing that every time we draw something. So that's 25. And then, so the only thing that I forgot to remove that line should be removed. Okay, so that's it. So with that, you are now in a position to extrude the crank sides. Now, like I said, the extrusion we will do here, we are not going to start at the profile plane. We are going to start as an offset plane. So that is why the extrusion is not starting from the profile plane, but it is starting offset. So we take the offset as a breadth of crank divided by 2. And then the thickness of the extrusion is leg. These are variables we've already defined. We should define these variables. And in this class, I'm going to show you how to do it. I will go out of my script now and show you how to describe how to do this type of thing. So let me first of all let's make the something small and get our Fusion 360. In Fusion 360, in any situation, you can always take your, if you are not in Sketch or doing anything, you can just take your modify, and when you take your modify, you can go, or you can use the drop down and go almost to the end, the second to the last thing there is said called change parameters. If you click it, you will see that you can select user parameters. If you select user parameters here, if you double click on it, you are able to what do I do now? The user parameter. So you can add a user parameter there, and you are given this. So let us say you want to say crank, the breadth of crank. Okay, BRE, BRE crank. Whatever name you like, you can put it is in millimeters. You can put any expression. You can put, say, if you want that to be 20 millimeters, just put 20 there. And then you can put a comment. This is the offset. That could be useful for you later on. If you say, okay, from this point now, if you call the name of that variable in any expression, it would make it 20. So you don't need to remember it is. And the advantage of it is that later on when you change it, it can change it in your drawing throughout, and your drawing can be adjusted. You can put another one. All you do is you say you add another parameter, and then here now if you say leg, and then you say the leg is 15. You don't even need to put a comment. When you put OK, it is going to give you a list of all the parameters you have defined, and you can use them instead of the explicitly making use of the distances given here. So once you are done, you say OK. So with that, so that's the kind of thing you are saying in that example. So let us go back to the slide and then do the slideshow from the current slide. So that is when you are saying offset, we say break crank divided by 2. So whatever value is in the break crank will be divided by 2, and that will be the distance given here. Here, when you say the distance of the extent of the extrusion is leg, is going to look for a variable called leg, which you have defined in that place, and it will use it. So, and if you change it in the place, it's going to change your drawing throughout. So that makes your drawing that makes your drawing parametric, because it's going to be based on those parameters that you choose. So it is very easy to make your drawings parametric. And then, so let me just go back up. So we are now to extrude the crank side. The extrusion dimensions are shown here. Instead of the profile plane, we do our extrusion from a plane offset by the distance break crank divided by 2 to a distance of leg. The two variables we are choosing have the values of 45 and 20 respectively. That is what was done in this particular drawing. Drawing variables can be created from modified drop down, and the mirror of this object along the YZ plane is done to achieve the picture below. So that is what we can do. And so this is the mirror. After you have created this, you can take a mirror of it for this other side. And this is what we just did. Modify, you go to change parameters. So that is it. The bodies created by this method are shown here. The drop down is also shown from which we can define or edit variables that we can use in our drawings instead of directly selecting numbers. From the modify menu, we can select the second to the last item, which we call change parameters. These values can be set or altered from the field boxes presented subsequently. So that is how you got that going. And similarly, after you have done that, we're going to have these two rectangle shape objects. Each one of them has either 2 or 3 rectangles. Again, like whenever you see fx preceding the number of a distance, it means that that was not got directly, it was got from a variable that was predefined. So that's the meaning of it's like a function. So that is what. So every time you see fx, that shows that we didn't just type here. We didn't just type 22.5. 22.5 was obtained by an expression that we use. So if you use 22.5, it will work. If you use 40 here, it will work. But we're just letting you know that is a parameter that was defined inside the drawing. So we proceed to do a single crank with 2 sketches on the ZX and YZ planes respectively. The profiles here are simple rectangles with small grooves that are small rectangles of 2 by 5 at the top. This is the 2 by 5, 2 by 5, and 2 by 5. Those are the grooves that are at the top. So when you see fx prefix, show the dimensions there was taken from a variable defined in the parameter list, as we discussed previously. So these are the profiles that I've showed you there. The dimensions of the profile have been given. So you are going to do revolve along these profiles. And once you do the revolve, let us see, there's a clip here. There's a video clip. Let us go through the video clip. So starting from the extrusion, and then after creating this this drawing on the ZX plane, so you are going to do a revolve, and then when you do the revolve, you are going to choose the axis of revolving, axis of revolution, and you will see what those two things will do. So from this point, you are going to choose revolve, create revolve, and it's asking you to choose the profile. So to choose the profile, that is the profile, one profile, and then that groove is another profile because both of them are closed. So then you select the revolve, the line of revolve. The line of revolve here is that line. And it is set to cut now, but you don't want it to cut. You want it to create a new body. Create a new body. So, and if you're happy with that, 360 degrees, you're happy with that, you select OK. Okay, so that is done. The next thing is to do the second revolve, that is create revolve. And that there are three profiles there, 1, 2, and 3. So then you are going to select the axis of revolving. The axis. Okay, so select the axis, so that's it. And then it is again a new body. It's not join. It's a new body you want there. And then you are happy, we're okay. So we're going to do mirroring now to finish what we want. So we're going to do mirrors 2 times. Create a mirror. And then we create a mirror. We've switched off the object. So we are going to join it with the object we are mirroring from. So if we're happy with that, click OK. So that is the first one. And then the second one, we're going to choose mirror again. We're going to choose a mirror again. So You should create mirror. That is what we want to mirror. And then you're going to select the mirror plane. The mirror plane here. Yes, that's the mirror plane. You're creating a new body. Join, no, new body. Okay. So we now have, go to the origin. Okay. So we have a single crank has been created. And the last thing left, let's see whether it is in this video. So, okay, so we have finished creating the crank, and we can continue now. So to complete the single crank, what we have to do now is to turn this thing into components. We make one of the side things a component on its own, and the remaining of it, we call it the crank. So just the way we've been doing. So just create these components. The only thing we did that we didn't show here is that we did filleting. We did filleting of all the sharp edges there. So we filleted these sharp edges, and that is the result of the work. So I think that is the end of the slides. Now I will go to spend about 5 minutes in the chat room. If you have questions, please ask them. I will answer you. So I'll wait for you in the chat room. So go there, present any questions that arise from this lecture, and let's see how we answer them. Well, if there are no new questions, I think the admin can close today's class, and then we'll see you again next week. I don't have any assignment for you now, other than practice all you have done, and then try and come up with project ideas from what we are doing here. Next class, we're going to begin to assemble some of the things we have done to make an engine. So the engine will be based on the individual components we have created, and you will now see the power of component making. When you get to assembly level, you cannot assemble bodies, but you can assemble components. That is why even after you have made the components, after you have made bodies, you need to turn them into components for the purpose of assembly. You will see we will do that from next lecture. Thank you. Bye-bye.